Hello everyone, welcome to our webinar on advanced steel for materials handling. Many of you have probably seen demonstrations of advanced steel in the past and possibly even own advanced steel. But what we tend to do in most demonstrations is start off with a portal frame building. That's not because that's all we can do, but it's just a nice quick way to achieve a lot in a short space of time. But what we thought we would do now is show you something slightly different. We've come up with a model based more around the materials handling area so that you can get a feel for how to approach slightly different things, show you some different aspects that might not include in other demos you've seen, and hopefully you can pick up a few tidbits and hints along the way, or just remind you that advanced steel can do a lot more than just portal frame buildings. So I'll finish the slideshow and go to advanced steel. Okay, so you don't want to watch me work out all the dimensions and beam sizes, so what I've got is a file. I've got some construction lines already drawn in to remove that boring part of the process from you. So the first thing I'm going to do is turn on the first lot of construction lines, like so. Okay, so what we're going to make is a conveyor belt with a hopper over the top to funnel the gravel or whatever it might be carrying onto the conveyor. So let me save this as a new file, and we can start drawing. So like I say, we've just got an ordinary Autocad lines just to save me having to work out the dimensions and bore you with that laborious stuff. But we're going to draw in some channels to start with. Let's check my snaps. Which ones do I want on? Let's turn endpoint on. And we want those to be reasonably substantial with the system line on the back. So that's going to be the length of our conveyor. We need some legs to hold that conveyor now, so I can use these lines with a couple of I-beams. They need to be small, so they're going to be the smallest one in the range, like so, and then go to the other side, and that one needs to be rotated so it's in the right place. Now I can put some joints on there. If you've not seen advanced steel before, then anytime we want to connect beams, it's very easy to do. We have a library of parametric intelligent joints, which we call the connection vault, and in there you can select any joints that you like for different purposes, and each time you hover over a joint name, you see you get some images with examples of that joint, and you get a text description of what that joint can achieve. You can also put the ones you use most on the page at the top called favorites. So I'm going to start with a base plate, and I simply have to pick the beam I want to apply the joint to, and there it has gone. It's created a base plate for me with the anchors. Now that one's quite huge, we don't need it that big, so I can look in the library for any stored configurations we may have. I can choose a nice smaller base plate there. That would be lovely. And then I need a joint for the top where we've got these beams clashing, and we need to make a connection there, so I can use this one, which is called gable wall end plate. Select the beams to apply it to, and again it's cut the beam down, or the column, put the plate and the bolts in. Again, that's rather too big for the bolts, so let's change that bolt size. Everything about these joints can be edited very easily. Just find the right options. You can play with the options. You get images helping you determine which option does what. That works for me. Now, for this situation, I've deliberately allowed a gap between the channel and the supporting frame so that we can use shims to get the channels level, or at whatever angle you need. So I'm actually going to use a joint from the Graitec Power Pack. Graitec have released a set of extra tools for advanced steel, which we call the Power Pack. There's nothing there you can't do manually in ordinary advanced steel, but we've just made enhancements, we've done macros, we've done extra joints, just to make life a little bit easier for people. The Power Pack is free to all Graitec customers, and it's available for purchase to other people who don't deal with Graitec already. So we have a joint here called connection at intersection, and I can choose the two beams that I want to apply that to as normal, and let's put some bolts in and a pack of plates. Now let's play with the settings there. So these plates, I want to make a pack of shims, so I'm going to say they're 2 mil each. And it's made now a pack of 5 plates in there. Obviously the bolts are rather huge, so we don't want that. Let's go down to the bolts page, and M12 will do for that. I only need 1 line of bolts, and the centers would be 75, 45. There you go. That looks reasonable to me. So that's enough to hold that on. Now we've got 1 copy of each joint that we want. I can use the standard tools here. We have a special tool called Joint Copy, or Create by Template on other installations. And I can select the joint I want to repeat, select where I want to put it, and it places exactly the same joint with exactly the same settings on the new member. So I'll do that for each of the 3 joints I've placed. And I don't need to set up all the parameters again, because it, like I say, it uses exactly the same parameters in the new location. So there you go, I now have the same joints on the other side. So that's 1 trestle or goal post, and I need the same thing now repeated along the length of my conveyor. So we can use the tool here called Transform Elements. I can select the beams that I want to copy, and I'll now tick the box saying include additional connections. You'll notice it jumps from 3 objects selected to 27. So it's found all the joints and all the members that belong to those joints automatically based on the beams. Now I need 8 more legs, and they'll be able to pitch in the Y direction of 1450. Now just to make sure I got that right and haven't fumbled, I can click Preview. And there you go, it's carried out the work. I can have a look. Yep, that looks good to me. So if I had done something wrong, I could click Modify and correct the entry I put in the dialog box, but I'm happy with that, so I just click OK. Now that's copied those joints all the way along, so if I isolate the channel, you can see it's got holes going all the way along in the right places. Okay, so far so good. Now to go on top of that channel, we're going to put some conveyor rollers. Now, Advanced Steel can show anything made by any CAD system. The members it's really interested in, and we'll do the drawings and fabrication details for, are the steel sections and plates and so on. But if you have another member, which is a mechanical member like a roller, a bearing, hinges, decorative parts for architectural steelwork, whatever, you can still use those and display them. So what I'm going to do, I have another file here that I've prepared, which is called Conveyor Drive Roll. And here's a big roll with a bearing block either side on that. Now what I've done in there, the 0, point needs to be like using a block in AutoCAD, that's your insertion point. Everything else in the file is just 3D solids, no blocks, no other elements, no meshes or surfaces, just 3D solids. But I have also put in a couple of AutoCAD points. Can you see the white dot there and there? Hopefully you can. These are just point objects in AutoCAD. But those are points that are significant to the block, so I can use those to lock onto when I insert them into the main model. So to insert that into the main model, I use the command special part, which is on the palette on the right. So Advanced Steel special part. Oh, I'll tell you what I forgot. Let's rotate the UCS. I want X going along the conveyor now. Then I do a special part. I want to put it on the end of the line there. And I then browse and I select the part I'm interested in. And it inserts the part. I could specify the weight if I was interested in lifting, and I can specify the behavior, whether or not I need to include this in my bills of materials and so on. If it's a part I have to buy, obviously I need to include it. But maybe it's just neighboring equipment, you're doing access platforms to existing machinery, then you obviously don't need to include it on your bill of materials. So you take these ticks out and it won't show on your lists. Okay, so I've got that in there. I need to bolt that onto the channels. So I just come along and I place a bolt pattern between these 2 objects. Now I said I put in some points, so because I inserted the point in the block originally in the special part, I can knock onto that using the node snap now to get that position that I need for the middle of that bolt group. Now I need only one bolt in that direction. No, it's the other direction. So 2 that way, 1 that way, and it needs to be 390 space. Right. I had them going upside down from something I did earlier, so just move them to the right position. There you go. So now the bolts are going through the bearing block and the channel. There's the holes in the channel. I'll do the same on the other side. So it remembers the settings for the last bolts I put in. I can lock onto that snap point. If the bolts do come up in the wrong flange, as I have done for me, it's not necessarily a mistake, it's just the way the logic works sometimes. So you can use this shift bolts and holes command to move them to the correct flange, like so. Okay, so that's the main drive roll. Now for the rest of the conveyor I want to make a bit of a scallop shape, so I have some different rolls I'm going to place in there, and I'm going to put that on the end of the line there. There you go. These will make a nice conveyor to keep the gravel in the middle of the trough. Again, I need to add bolts to those. I need to go halfway between the two holes for the middle of my pattern. And that would be slightly smaller. There you go. Same at the back. And again, it remembers the previous settings, so they're in the right spacing. So that's the carry rollers, if you want to call them that. And I want lots of those as well. So I'll use the transform elements again, and I'll select the roller. I'll select the bolts on that side and the bolts on this side. And this time I want 10 copies. Try that again. Didn't mean to press return. This time I need to go in the X direction, and it's in the minus X direction, so it'll be minus 1000. So I'll click a preview just to make sure I've not fumbled anything. Yep, that looks good. So I can say OK again. And like I said before, when you copy all that, it copies all the bolt holes and everything along correctly. So that's our conveyor and the rollers on the trestles. The next thing we're going to do is actually draw on a belt, because maybe you just need a bit of context here and it looks better on the GA drawings. You wouldn't necessarily, you certainly wouldn't manufacture from this, it's just a visual representation. So I can finish with those construction lines. I'll turn on some here. So just done here, this is the shape I want the belt to be. I've drawn it in as a polyline, standard AutoCAD polyline. Now anything you can draw as a shape, you can make a beam of if it's an open shape. You have a command here called folded beam. So if I select that command, I want to tell it it's coming from a polyline. And I select the line. And then I tell it where the system line goes relative to that shape. Now where I'm actually going to draw the beam, well, I'm going to draw it from the middle there, going that way, 10.5 meters. I only would need that to be 5 mil thick. And I'm going to put a little radius in the corner because it's not really going to be a sharp fold. Okay, so there you go, there's my belt, the majority of my belt. But it's coming off the drive roller and it's going down to there. So to make this sort of deforming shape, I'm going to use something we call a twisted folded plate. And it's going to go from this line here to the poly line there. Again, it only needs to be 5 thick. And that's a reasonable approximation of the shape for visual purposes. So I've got those two nice objects now. I can select them and I'm going to put them onto this layer, concrete footings. Just so they look a bit more like rubber. So there you go, there's my conveyor put along just for visual representation, nothing real, but it makes you recognize what it is you're working for. Okay, so I'll save. Then we said we were going to put a hopper over this, so the idea is maybe a digger's shoveling up the gravel, going to pour it into the hopper, it's going to drop onto the conveyor belt to get taken away for processing. So I have some construction lines for that as well. The hopper is going to be held up by a platform, so first of all I need to draw some columns. So I can draw one column and select the right sizes. This is going to be a column, universal column. Again, nice and small, it doesn't have to be huge, we're only doing a small structure here. It's going to be in the center, it needs to be rotated. That's good. Now on the bottom of that I'm going to put a base plate. When Advanced Steel places a joint, it has a library of each joint of pre-configured connection arrangements, properties, dimensions, bolt centers, everything, and it looks up in there one that matches the beam. So we've already got a predefined list here. In the UK we've got this publication called the BCSA Green Book, where the authority or the institute that controls the structural steelwork in Britain have published pre-calculated joint parameters. So it's automatically chosen one that's appropriate to that column. I don't really need to argue with that, so I'm going to happily just leave it on the standard this time. And now I'm going to copy that column to the other positions that I need it. Just use the standard advanced copy tool, and because I've told it already that I want to include the joints, the base plate goes with it each time. So that makes life a lot faster there. Now at the top, to support things, we're going to use some channels. So I go for the channel shape, and I'm going to go along my construction lines. Oh, that one's in the wrong place. Like so. That needs to be a little bit more substantial. Make sure the system line's in the right place there. So this one was wrong, let's draw that one again. There you go. Going across the middle here, I need an I-beam, because I need to connect both sides of that. So it would be a beam. I'm going to use a reasonable size one so I've got enough flange width to connect to. And I need that on the right side of the line, so I'll put it on that side of the line there. Okay. Get this in the right place as well. Nice, there you go. Now I've got the beams drawn, I can put the connections on them. So come back to our connection bolt. I'm going to use a single-sided end plate joint for a simple arrangement of connection here and put it in here. So this time it hasn't chosen the right size for me automatically, so I just simply go to the library and have a look at our list of configured sizes, and the one I want is down the bottom here. Now that's done a nice arrangement for that joint, so I'm happy with that. And now again I can use our joint copy. Now I've got lots of places I want to put the same joint on, so I can use joint copy multiple, or if you're in another country, create by template multiple. And I can choose all the locations I need to put it on in one go. So I'm going to put it on all those columns and all those beams. And it's put the joints on all the way around for me there. Obviously the I-beam needs a different configuration, so I'll put those on separately. Okay, so in the middle here I need to connect both sides of that channel, so I can't do that with the one beam going through each other, so I need to split that beam. So I'll tell it to split the I-beam at the end of that one. So now I have two separate beams, so I can place a double-sided end plate trimming the I-beam back appropriately around there. Okay, so that's given me my platform support, so let's put the hopper in then. So the hopper, in fact let's clear the decks a bit first. You can see I've drawn in two construction lines here. I've got this square with curved corners and the one down here, square with curved corners. They're just polylines, using standard Autocad polylines to make those closed shapes. And we can make the hopper now in one go, run the move using our command conical folded plate. So it's a contour that I want to select, and I'm going to select the line there. And then it's a contour I need to select for the bottom. And there is the folded shape. Very, very easy. Now that's not going to float there by itself, so it needs some mounting flanges around the top to bolt onto the structure. So I'm going to use a extra plate command here. I want one on each edge, so I'm going to go for the middle of that edge. Tell you what I forgot, let's undo that. I need to put my coordinates at the top so it knows where the plate's going to go. And I'll draw a plate on the middle of that edge. So the dimensions are going to be 1100 that way, yep, 100 that way, yep. And the positioning, although originally the command said create plate by center, I can use these dots to move the plate around to get different positions. So that's the correct direction I wanted to move at that time. I'm going to put another one on the middle of this edge. Same size, play with the dots until I find the right position. That's the right position. Want one that side. Now I need to swap the dimensions around, so that'd be 100 that way, 1100 that way, and play with the dots. There you go, got the right one that time. The last one, let's put the plates on. Now those plates are just independent plates at the moment, but using the tools in Advanced Steel we can make them all into one piece. So we've got this tool here, create a folded plate without position adjustment. So the plates are already in the right positions, I just need to join them together. So I use that command, so I want to connect that plate to that plate, and it puts the fold in between the two objects. So I'll repeat that as I go around. I want to connect that plate to that plate. Connect that plate and that plate, and connect that plate to that plate. You could convert the angle and you can play with the radius in there, but I'm happy enough accepting the defaults for now. So now that's all one piece. I need to bolt that onto the platform. It's not just going to sit there. So I can place bolts between that part and that part. Now, even though that's a rectangular plate, I can still use a center snap to find the middle of that rectangle. So I'm going to do that because that's a nice position to center my bolts around. So there you go, I center snap. And these bolts need to be a bit more substantial, so they'll be M20s. I want 5 of them at a 250 spacing. Yep, that's good. And I'll do another set through these objects on this side, so it's through the plate and that channel. Center snap to find the middle of the flange. Smashing. Same again on each edge. And again, I'll have to just swap those dimensions around. So it'll be 1 that way, 5 that way, the 250 spacing that way. Not midpoint, center. Smashing. Okay, so we've got our hopper completed now. If you want to have a look at it as a flat pattern, you can simply go to the advanced properties by double clicking on it, go to the display type page and choose unfolded. And there you go, there's the flat pattern of that hopper. You can see the flanges with the holes in, you can see the bends, it goes around the corners, everything there. And when you're happy, you can go back to standard presentation to see it folded up again. Things are coming on nicely. So the reason we've got a much bigger platform than just the square for the hopper is because somebody might need to get up there and get to the top of the hopper, get access there. So we need to give them something to stand on, and that'll be a piece of grating. So as well as doing ordinary plates, we can do gratings. So just ask for a variable grating across this gap here. And you can see we have a range of different suppliers from around the world. And you can choose different sizes once you've chosen the supplier. Now the grating there, I've just used it exactly on the gap at the moment, but I need to make that a little bit bigger because obviously it wants to sit on the beams. So I can just use the grips on each edge, select the grip and move it the direction I want to go. So I can move these out to cover the channels each direction. Okay, there's my grating. Now we want to make sure he doesn't fall off of this platform, so I want to put some railing in. Now to do the railing, we have a railing macro, which will put in lots of parts for us in one go. So I can start off on that beam, then along that beam, and then along this beam, and finally along that beam. Oh, try that again, fumbled something there. That beam, that beam. This box you may have seen popping up, something I've turned on called cycle selection. In 3D sometimes it picks the object to the back or at the front or somewhere else, and it's not the object you wanted. So whenever it's ambiguous, if you have cycle selection turned on, then it gives you a menu of all the things you might have been picking, and you can point at the right one in the menu and select it from there, just to make sure there's no ambiguity. So if I click here, again, I could have been choosing different things, and it's that one I wanted. So I want to start there, come all the way around and end there. No, I don't need a reference point. And there you go, let's put some grating along those beams, railing. Now, the railing has many, many options we can play with. But once you've gone through all those options at length, maybe the first time you do it, you'll probably use a similar railing quite frequently. So I've got the samples and things set up in the library, so I can just choose one of those. And it reconfigures the whole railing. It's now mounted on the side of the beams. It's got different middle rails and so on to suit my general preference. But on this occasion, I don't want those looped ends, so I can come down here and I can choose the options and turn off those looped ends. This doesn't mess up what's in the library. This is just for this one occasion. I need to put back the middle rails. Okay, I might move the start point along a little bit, so I can go there and move it maybe 100 mil, so that, there you go, that moved up a bit there. And now I want to make sure it doesn't walk into the hopper or fall into the hopper. I can join the railing up across that gap. So if we go to the connection vault, we have a particular joint for that, a railing handrail joint. I want to connect that beam to that beam. Well, I can leave it on a mitre, but I want that weld to be done on site. And then I can repeat that joint between that and that, and between that and that. Okay, so it's fairly simplistic, but you get the idea. There's a nice railing now holding him safely up there. Now the last thing we've got to do is tell him how to get up there. You can't just float, so we're going to put a ladder up to that platform. When you're doing a cage ladder, you need to make sure the y-axis is pointing in the direction of the climber. So let's get my coordinates into a recognizable location and rotate them so that y is pointing on the side the climber will stand on. That's it. And now I can use the cage ladder macro from the bottom of there going upwards. And we've got a ladder. Now we need to set the properties appropriately. So the height should be 3200. It's not going to clash with the wall. It's embedded here at the moment. Need to move it forward from that. So I'm going to say I need a folded plate bracket. And the first bracket is 3100 up. Now he needs to climb off the front of that, so we need to change the exit. So we have 6 different styles of exit, and it happens to be type 6 that I want. It gets wider but stays parallel. Then I go to exit dimensions and I can change the options here. So I need to go wider by a fixed distance of 150 each side. That's good. And I'll make those go up a little bit higher. Smashing. So now you've got a ladder, he can climb up and climb out the front onto the platform. So let's hide the boxes and things, and that's basically now my finished model. So that hasn't taken too long to achieve that. Just as a finishing touch, let's produce an arrangement drawing of that. Now, if you've seen demos before, you'll know that arrangements are created using a tool called cameras, and rather than set them all up live, which is repetitive, I've already set them up in advance here. So we have these objects saying I want to create a drawing. This one, for example, would be looking down in plan, and you have various properties in there about what you're going to show and how you want to show it. So now I can go to our drawing processes and tell it I want to draw all the cameras on an A0 sheet. And I'll give that just a couple of seconds to do the job. Okay, that's created my 4 views. So I can select any part, right click and say show camera detail. There's my drawing. Now it's laid out the views in a fairly random sequence, so I might want to rearrange those, so I can just select that outer green frame, click and drag to where I want it to be. So if I start off with that one over there, if I want to line them up accurately, then I can use the Autocad Move command to help with that. I want to move that view, and I want to go from the endpoint on the top of that ladder, and I want to line up with the endpoint on this view. So if I have down here object snap tracking turned on, then I can line up, and it's anytime I see that dotted line on across the screen there, I'm lining up with that tracking point, so I want to go there. So now I know those 2 views line up perfectly. And I'll do the same for the top view. I want to line up with the end of that. Somewhere like that. And that gives me plenty of room now for this isometric. But actually I think I could probably make it a bit bigger. So if I want to change the scale, I can just double click on that frame, choose a different scale and say OK. And there it is, drawn to a bigger scale. So that's a nice drawing, like that. I'll save that now. I've made some changes. I'll close that. Just in case you think I'm cheating too much by putting the cameras in first, I'll do one new one for you now, live. So I want to draw just the platform, not the whole belt, from this sort of direction. So I can rotate the screen how I like to get the direction I want to look in. So that's quite nice. I can use the coordinate command here, UCS view, to match my coordinates to the view. And then I create a camera based on that. I can put the camera here. So this will be platform, will be the name of the view. Now, because I don't want to show everything this time, I need to limit the area I do show. So I can guess roughly the size, and I'll choose a different style. I'll let the system choose the scale. So that's roughly the size, a little bit out maybe. So what I can do, I can just literally use the move command to move that camera down a bit. Still not quite covering the top and bottom. So I can select that. I can use the grips to make it grow, and it grows equally both ways. So the width is nice. Now the height is covering everything I want nicely. That's great. So I can just select that camera now. On my drawing processes, I say give me the selected camera. Let's use an A2 sheet this time. And there's my drawing of just that portion of the model. So you've got the railings. Yellow doesn't show great on a white background. You've got the stair, ladder, you've got the belt, everything there. So there you go. Advanced Steel can do a lot more than just portal frame buildings. You can basically model pretty much anything you like. And if you need to have mechanical equipment or purchase components, you can use special parts to bring them in, like we did for these rollers. So I hope you found that interesting and enjoyable. Thank you for your time and your patience, and we'll make available a recording of this for you after the end of the session. Thanks very much.